Hello, this is Walker Physics 4th edition. We're in Chapter 7 on work and kinetic energy, and this is number 47 from the end of the chapter questions. You raise a bucket of water from the bottom of a deep well. If your power output is 108 watts, and the mass of the bucket and the water in it is 5 kilograms, with what speed can you raise the bucket? Okay, ignoring the rope. All right. Now, if you remember what we did before, we're going to see that that you've got that a watt, right, is a joule over a second. Okay, let's just write ourselves some notes. A watt is a joule per second. It's how many joules of work are being done on something per second. So it's a unit of power is force is work per time. Okay, work divided by time. All right. If you remember, a joule is a Newton meter. Okay, a joule is a Newton times a meter. Well, if I have a work, then I could say work is a Newton times a meter divided by a second. Well, in that case, I could also just make it as easy as that could be and just say Newton is force times velocity. All right. So watts, this is watts, W is watts, it's power actually, is force, it's force times velocity. All right, do you see that? So work, a watts is joules per second, a joule is a Newton meter. A Newton meter per second is power, it's watts. That means Newton times meters per second, which is velocity. So that's force times velocity. And we're going to use that. It's going to be a very simple problem once you understand that much. You're just going to plug it in. So I've got the work as 108 watts. And they know that it's 5 kilograms, so I need to know its weight. Remember, force is weight. It's mg. It's its kilogram mass times gravity. So this is going to be 5 times 9.81. All right. So 108 equals 49.05 times what meters per second? Well, that's what I'm trying to find. X meters per second is what I'm trying to find. So I'm going to take 108 and divide it by 49.05. And I have 2.2 meters per second. Okay, pretty cool question, I think.